Hello and welcome back to Saxon Math. This is lesson 90, measuring turns. Every hour, the minute hand of a clock completes one full turn in a clockwise direction. How many degrees does the minute hand turn in an hour? So thinking about that, turns can be measured in degrees. A full turn is 360 degrees. So the minute hand turns 360 degrees in 1 hour. If you turn 360 degrees, you will end up facing the same direction you were facing before you turned. A half turn of 360 degrees, which is 180 degrees. If you turn 180 degrees, you will end up facing opposite the direction you were facing before you turned. If you are facing north and turn 90 degrees, you will end up facing either east or west, depending on the direction in which you turned. To avoid confusion, we often specify the direction of a turn as well as the measure of the turn. Sometimes the direction can be described as being to the right or to the left. Other times it is described as clockwise or counterclockwise. So compass rose, when we look at it, you see north is to the top, west is to the left, east is to the right, south is down. So if you're traveling north and you turn 90 degrees, you'll be either facing east or west depending on the way you turn. So if you turn right, if you're traveling north, you'll be facing east. If you travel left while you're traveling north, if you turn left, you'll be facing west. So if Layla was traveling north, at the light, she turned 90 degrees to the left and traveled 1 block to the next intersection. At that intersection, she turned 90 degrees to the left again. What direction was Leela traveling? A picture may help us answer this question. Leela was traveling north when she turned 90 to the left. After that first turn, Leela was traveling west. When she turned 90 degrees to the left a second time, she began traveling to the south. Notice that the two turns in the same direction total 180 degrees. So we would expect that after the 2 hours, Leela was heading in the opposite direction to her starting direction. So she would be going south in this case. North, this direction, west, this direction, south, that direction. Example 2, Andy and Barney were both facing north. Andy made a quarter turn 90 degrees clockwise to the face east. So 90-degree turn is clockwise, would be going this direction right here. And a 90-degree turn makes him face east if he's going north to begin with. While Barney turned counterclockwise until he faced east. So Barney went the other direction. So he went all the way around this direction, counterclockwise. How many degrees would that have been for him to make that east-facing direction? So we can draw 2 turns. Andy made a quarter turn to turn clockwise, and we see that Barney made a 3/4 turn to turn counterclockwise. We can calculate the number of degrees in 3/4 of a turn by finding 3/4 of 360. So 3/4 times 360 is the same as 3 times 360 divided by 4, or 360 divided by 4 times 3, which equals 270 degrees. If you were facing this way, this would be 90 degrees. Here's another 90 degrees if he's facing south, and he went an additional 90 degrees. So this was 90 plus 90 plus 90, and that'd be 90 times 3 also, which was 270 degrees. So another way to find that would be to recognize that Barney turned 270 degrees counterclockwise to face east. Example 3, as Elizabeth ran each lap around the park, she made 6 turns to the left and no turns to the right. What was the average number of degrees of each turn? We're not given any of the measure of any of the turns, but we know that Elizabeth made 6 turns to the left to get completely around the park. That is, after 6 turns, she once again faced the same direction she faced before the first turn. So after 6 turns, she had a total of 360 degrees. We find the average number of degrees by each turn by dividing 360 by 6. So we now know that the average turn that she made was 60 degrees for each of those. So the number of laps Elizabeth ran does not affect the answer because it's simply we're looking for 360 divided by 6, which is the number of turns that were made. All right, let's try this. So for part A, Jose was heading south on his bike. When he reached Sycamore, he turned 90 degrees to the right. Remember, he's going south here. He's going to turn 90 degrees to the right. So that's this direction. If you're facing this way and you're going to turn right, you're going to go to our left as we're looking at it. Then at Highland, he turned 90 degrees to the right again, and at Elkins, he turned 90 degrees to the right again. Assuming each street was straight, in which direction was Jose heading on Elkins? So here he's heading south on his bicycle on Sycamore. He turned 90 degrees to the right, and then at Highland, he turned 90 degrees to the right again. And then at Elkins, he turned 90 degrees to the right on that one, finally. So in which direction was Jose heading? He would be going east, because east is to the right. So east is the best answer for that. Letter B, Kiara made 1 full turn counterclockwise. Let me just show you. Counterclockwise is this direction. Counterclockwise goes that direction. Mary made 2 full turns clockwise. So Mary was going the other direction, and she went 2 full turns. How many degrees did Mary turn? So guess what? When doing this, Kiara made 1 full turn counterclockwise is nonsense information. We don't even need it to answer this question. Mary made 2 full turns clockwise. How many degrees did she turn? Well, from here to here, so if she started here and she's going this direction all the way around, that's 360. That's 1 turn. So going 1 turn is 360. Going 2 turns would be adding up those together, and you'd end up with 720 degrees for how many Mary turned clockwise. So that would be 720 degrees. And letter C, David ran 3 laps around the park. On each lap, he made 5 turns to the left and no turns to the right. What was the average number of degrees in each of David's turns? Draw a picture of the problem. So if he's turning 3 laps around the park and he's turning left and making no turns to the right, there's 1, 2, 3, 4, and 5. So if this is his starting point, here's 1, 2, 3, 4, 5 turns that he made. The average number of degrees is simply 360 divided by 5 because there's 5 turns. 1, 2, 3, 4, 5. So once we figure out what 360 divided by 5 is, we know what the average number of degrees in each turn will be. So this would be close to that. That'd be 72. So 72 degrees for each of these turns. 72 degrees. 72 degrees. And how did we know that it was dividing 360? Because if you're going this direction and you make your complete revolution and you continue to go back in this direction, you're facing that same direction, no matter what that direction is. So if you're going that direction and you do as many turns as you want, and then you're facing this direction again, that is a 360. That's 360 degrees in that turn. So if you break that turn into many different turns, like if you make all left turns there, depending on the number of turns, it's just 360 divided by that number of turns that you made. So David's average degrees of each of those turns would be 72 degrees. And that would be your final answer. All right, excellent work today. Make sure you do all of your written practice 1 through 30. It's very important. All right, have a good night.